Hello and welcome to TechEFX. I'm Amar Kumar. In this video, I'm going to explain you DevOps, how it can help you to accelerate your software delivery process, its technical capabilities, end-to-end DevOps implementation journey, along with its right tool proliferation for all its phases. During the session, I'll also highlight some of the issues or challenges faced when you're not practicing DevOps. I'm sure this session will help you doing right DevOps strategic planning and implementation. So let's get started. Many of you must have already familiar with the DevOps term and at least know basics of it. Those who are new to DevOps, I'll quickly explain what is the DevOps, how it can seamlessly collaborate with your development and operation team. If you Google it, you will get hundreds of definitions and almost all are correct. In my opinion, it is a process or practice within an organization that increase the collaboration, communication, and integration between the development, testing, and operation teams. Before we get into DevOps and its best practice, let's quickly cover the typical development cycle without DevOps. In that scenario, development team gets the requirement detail, sets the development environment, and starts building the codes. After building, developer commits the code to the version control repository. From that repository, code is manually pulled by build server for a specific build. In this created test environment and pushed to the test server. Once the build is deployed, test team access the application and do the round of quality assurance checks. If any issues are identified, it is entered in the issue tracker. From that tracker, issues are assigned to available development resource pool to fix it. Once this fixes cycle completes, the build is given to operation team to deploy on staging server and production server respectively. Up to here, everything looks fine. The problem occurs when issues are caught on the production environment. Many times, it becomes tedious for the operation team to handle the issue and they need help from development team to mitigate this issue on priority. This may lead to serious problem. How DevOps can solve such intermittent issues, we will see in our upcoming slides. DevOps mainly focuses on four phases, and these are continuous integration, continuous testing, continuous deployment, and continuous monitoring. These are the standard HLC phases. As you know, planning phase comes before the development phase, where requirement documentation, architecture designing, delivery planning, etc. happens. Coding phase is basically construction phase that includes unit testing. Building phase are mainly project bundling and integration activities. Testing phase is mainly functional and non-functional testing. Release is basically project shipment phase. Deploy does the application launching on specific environment like app server or native environment. Monitoring is basically post-production phase where application uptime, network monitoring, and business transaction monitoring etc. happens. As you can see, continuous integration is majorly integrating coding and building phase in a continuous manner. Continuous test is one level above on continuous integration and it ensures that test cycle execution on every build changes. When particular build is completely error-free and ready to deploy is called continuous delivery. Continuous delivery seamlessly integrated with continuous deployment enables the capability of anytime and anywhere deployment. And most importantly, when we stitch all these phases, we achieve DevOps. Now, let's talk about the core of the DevOps in terms of implementation journey. In this scenario, we will talk about the various processes or techniques and later we will identify the right tools proliferation for all these processes which we cover. So first thing, we get a requirement from business or internal team. Identify right skill resources and set up a development team. Development team further sets up an integrated development environment for code construction. This ID directly gets integrated with source code management system as a continuous integration. Means developer will be able to create, update or edit codes, pull the latest codes from version control system and all is happening while doing coding. You need to integrate the entire project to a continuous build system. You can script the entire build process like compiling, adding required libraries, system property attributes, integrating APIs, and bundling the project in different formats. Next is to integrate continuous quality. In DevOps, you can bring the quality review capability like static or dynamic code review, security and compliance checklist review, etc., while you are still in construction phase. This can be implemented in later phases of development cycle as well, for example, in SIT as well. Next, adding the continuous testing into your development cycle means you can run automated functional scripts before you are actually passing it to testing team. Likewise, you can also integrate continuous performance capability to next operation part. This brings single or multiple applications, server nodes, or any containerized environment. For example, is a Docker. And finally, you have integrate the application with continuous monitoring. For example, uptime monitoring, business transaction monitoring, through application performance monitoring, network usage monitoring, etc. Now, I will explain you the right tools proliferation for all these stages what we discussed. For integrated development environment, you can use tools like Eclipse or IntelliJ or any similar editors. For source code management tool, you can go with Git, which is very powerful and can also go with popular tool like Subversion, CVS, VSS, etc. For continuous build, Maven, Gradle, and anytime all-time favorite Ant. For continuous code quality checks, there are hundreds of tools available. I'll personally recommend you to integrate with SonarQube, which is very powerful tool for code quality and compliance check. You can also integrate with security and compliance tools explicitly. For doing continuous testing, you can use Selenium or HPUFT or any other similar tool. For performance testing, you can use widely used JMeter or HP Load Runner. For deployment, you can use Chef, Puppet, and even Ansible. For uptime and resource monitoring, you can use Nagios, Zabbix, or even Centrion. For business tasks or any APM tool. Now let's conclude DevOps benefit. It accelerates software delivery through continuous delivery model. Balance cost, quality, and risk by enabling continuous process checklists. And traceability by automating continuous delivery process. High availability and reliability through continuous monitoring. Fast customer feedback loop helps continuous improvement, and it improves team communication and collaboration. Let me highlight some of the DevOps findings. DevOps can accelerate 200 times more frequent deployment. DevOps can bring 24 times faster recovery from failure. DevOps can deploy 30 times more frequent with 50% of failure. DevOps can make 50% less time spent remediating the security issues. Please like and subscribe my channel and hit the bell icon to get latest update. Or any code smears or anything, I will quickly walk you through with that as well. And the fourth step is deploy an application server. Here I'm using Tomcat as an application server, Tomcat 9. So I'm deploying on that. So this is what is the step. So here, because here I'm trying to run manually because I have not done any scheduled run or any poll running. The meaning of poll running is you have the facility of even checking that if there is any changes in SVN code base, then only the build will, then only the entire delivery pipeline will be triggered. Else, if there is no changes, it will not be triggered. However, it's scheduled, but it will not be triggered. So as you can see, I'll just open it and I'll show you. So I'm going to code pull. So this is the name, the stage name, what you can put over here. And if you go down, this is what the SVN, my SVN repository address. I'm using simple SVN. And as you can see here, there are two options. If you click on build periodically, it allows you to put a cron tab syntax. So you can put a cron tab syntax and you can schedule your build. Say like every night by 9 o'clock or every midnight or early morning, you can automatically check for a build and you can create a build and deploy on the server. The second option is poll SCM. Almost all version control system provides the SCM polling. What SCM polling is, every there are certain frequency which is provided by a particular version control, and this Jenkins will be communicating to that version control server on that period, and it will check is there any changes, is there any version control, version changes available. If it finds any even minor version control change, that pipeline will be executed. So because I have not enabled this both thing, so it's fine. So that's the reason I am triggering it manually. So now I'm going back and I'll trigger. So as you can see, the total, the last time, it shows that last total build time, it was 2 minutes 8 seconds. So when I click this build, it will show the cumulative builds time, that consumption time over here. And the same time, you can also get individual time taken for particular that stage. Whatever that task it is doing, you can also get that. As you can see, let me zoom it little bit for you. So as you can see, 29 seconds. The last time when I ran, it had taken 29 seconds. For create build, it was 8 seconds, and static code review, it was 24 seconds. So now I'm executing demo application. So as you can see, that trigger started, and now you can see over here the code pull from SVN repository started. The best thing is it is giving you the real-time view and the real-time the time how much it takes. As you can see, that is getting executed. And the same time, if you click on it, it will directly take you to log. So basically, it's pulling the new bundle from SVN and doing the further processes. Now going back. So as I've shown you that you can actually visualize what is exactly happening behind the scene and in front of you. So this was the capability of delivery pipeline. So now, as you can see, the previous stage was clean. That's the reason is green. So now second stage is also completed with the green. So now it has gone to third stage, where static code review with SonarQube. So basically, like I have integrated internally with Maven with SonarQube. So if you go and see the log file, you will see that is basically calling a SonarQube. So I'm going to. So as you can see, look, the Sonar Maven plugin is getting called. This is the URL of my Sonar, which is running on port 9000 on the same machine, and build is success and finished successfully. So now I'm going back. And now this is also green, as you can see. So now fourth deploy on application server. 2 minutes 19 seconds so far. And now this deployment started. At the same time, you can also see here like what is the current status. This is another way of going to console output if you are well versed with Jenkins. So now you can see deploying web application. So the container is getting executed, and now the components are getting loaded. So this is basically a Hibernate components, and now it's saying server startup in 52 seconds. It took 52 seconds here. So I'm going back to delivery pipeline. Because I have not put any exit clause in that Maven script, and by the way, I'm using ant run inside the Maven. So if I click over here, if I go to script, I'll show you. You see here, parent pom is pom.xml, and my goal is ant run colon run. So what I'm doing, I've written a ant script which is getting executed inside a Maven script. So that's also possible. Because what I personally believe that Ant has got a better Tomcat control. You can start, stop in a Tomcat. You can have a proper authentication process in a Tomcat, and all you can do through Ant. So I feel I'm compatible with the Ant script rather, like writing a Tomcat execution script in Maven. So here, because I have not, as I mentioned earlier as well, because I have not made any, not put exit criteria. So it will be keep on running. So now let me open a application. So you can see I'm running Tomcat on 8081 port. So the application is up. So now for a demo purpose, what I will do, I'll try to make some runtime modification in a data part. So I'm just writing 454545 or something like that, correct? So employer adding new candidate. So this is what you can do with delivery pipeline. So the good thing is you can even switch on, switch off, exit, or execute the stages within a pipeline. So now if I click on this button, it will be exited. This particular stage will be exited. Or you click over here. This is the basically traditional way of the Jenkins. If you want to kill any tasks, you can click on this button. But here, just to show you the capability. So now the total build time of this. So basically, it's not build time. That includes the Tomcat execution time as well. But again, you can put a configuration such a way that then you can come out and let the Tomcat be running in a background as a daemon task. That also is possible. Now I'll quickly tell you how easy it is to even modify this workflow. As you can see, these 4 stages are in sequence, right? So it means it will run one after other. Now I'll tell you very quickly, like we can even create a complex workflow where you can have a parallel task running together, or you can have a recursive task designs, whatever way you want. I'll quickly add one more task in this workflow, and then we will try to alter parallel task. So another task called unit testing. So I'll open this. So here there's in build trigger, there is an option build after other projects are built. So here currently it's individual. So what I will do, I will put previous task as a create build and say apply and okay. Now if you go to look, and I will open deploy to Tomcat. I'll go to configuration. And I will select static code review as well as unit testing. So now I'm putting two dependencies rather putting one, which was there for the sequence. So you can have multiple dependencies that build after the other projects we do. So multiple dependencies you can put over here. So now if I go back to you can see now there are basically two executions. So now I'll quickly run this. So first stage runs as usual. First job is completed. Now, once the job completes, as you can see over here, both tasks has to be run parallelly. Look at this, both tasks, and look at the execution. Both are running in parallel. So if you look at the start time capture, 1939:45, 1939:45. There are possibilities that one task will end up sooner or later compared to each other. That's different. But one thing is sure that deploy on application server will only get executed when both tasks are completed. So if only one task completes, it deploy on application server will wait for other tasks also to be completed. Then only it will be executed. If any of one task gets failed, the deploy on application server task will not be executed. So as you can see, static code review task is completing faster. Still running. So static code review job is completed, but execution job is not yet completed. So as you can see here, it is not running, it's waiting for unit test jobs to be completed, then only it will be executed. As you can see, it's in pending state. So now you see it started running. So now it will run. Deploy to Tomcat will start running. Now I'm taking you to SonarQube for showing you a static code review dashboard for the application which we have executed as part of our job in delivery pipeline. So I'm logging. So this is what the SonarQube homepage. Here you can see this one project called DevOps Demo 1, and the quality gate is passed. And you can see one bug is identified and two vulnerability. There are 162 code smells. Code coverage, it is showing 0, and duplication is showing 0. And you can see here the date and time of execution is December 10th. So now I'm clicking on DevOps Demo. This is the detailed dashboard you can see. And from here, you can go and find the exactly where the bug is, in which source file and in which method. So this is the source file called employee.java, and this is the method where the vulnerability is there. So this is what you can get as a capability, and you can stitch it to delivery pipeline. So I'm not going to deep dive into SonarQube as of now. I will be having a separate session where I will show you how to effectively do static code review and how to quickly fix your bugs. There are many features available in SonarQube. If you use that SonarQube, it will definitely help you to quickly fix your technical debts. I'm going back now to delivery pipeline. Let me just quickly summarize that this is what the capability of delivery pipeline plugin 1.4.0, and it's completely scriptless. You just need to create jobs, and you have to define upstream and downstream dependencies. You just need to put the first order, the first stage, that initial job, and then later all these things will be stitched together. I have shown you how to update or edit or alter the pipeline and how easy it is to have a parallel execution or to have a sequence execution, or even you can alter, you can put new jobs in between while you have already created. If you're using Jenkins, I'm sure this information will help you to set up delivery pipeline to automate your DevOps tasks. Please like and subscribe my channel and click on the bell icon to get latest video updates. Thanks for watching. You must have seen similar to this infinite diagram in several occasions which depicts continual process integration of development and operations. You may also be familiar with similar diagram where you get tons of open source or closed source tools offerings for each of its stages. Still, for vast majority of organizations, identifying the DevOps process for automation improvement, selecting the right tools for that process, and most importantly, building the team with the right skill sets is still a challenge. In this video, we will learn how you can start seamless DevOps practices and build a skilled DevOps team for DevOps implementation in your organization to achieve single objective of DevOps delivery if you are a DevOps startup. Hello and welcome to my YouTube channel. I am Amar Kumar. We will focus on these three key components: understand DevOps roadmap and build DevOps team with clear segregation of roles and responsibilities, infrastructural readiness of hardware and software. We'll talk about successful DevOps implementation secrets. Let's get started. Before we talk about DevOps roadmap, let me quickly brief you about DevOps continual processes. To embrace DevOps in your organization, it is imperative to understand its processes and how it can build collaborative culture by adding on automation, resulting faster and more frequent releases through its continuous delivery model. Continuous delivery is the collaboration of continuous development, continuous testing, continuous deployment, and continuous monitoring processes. If you are new to my channel, I will request you to watch my previous video on what is DevOps and how DevOps can accelerate the software delivery. I have explained about continuous delivery processes. Now let's understand what skills are required to build a successful DevOps team through this very well elaborated DevOps roadmap diagram. I am referring this DevOps roadmap diagram from roadmap.sh website. You can find the URL of this page in my description box below. DevOps team should have clear understanding of one or more programming language as per your technology needs like Java, Python, Go, Ruby, C++, and all. It doesn't matter which language you use. Important is to get programming knowledge for automation. As you know, automation is the backbone of DevOps philosophy. DevOps team should build understanding of operating system concepts like process management, IO management, file systems, virtualizations, networking concepts, memory, and storage management. Team must be aware about what systems like Linux, Windows, or Unix and their variants. Linux operating system variants like SUSE Linux, Debian, Ubuntu, Fedora, CentOS, and Red Hat Enterprise Linux. Unix variants are like FreeBSD, OpenBSD, and NetBSD. Objective is to learn about managing servers. Team should also learn to run commands on terminals like shell scripting, text manipulation tools like AWK, SED, grep, sort, etc. Text editors like Emacs, VIM, PowerShell, and all. Processes monitoring like PS, Top, ISOF, and all. How to compile apps from sources like Make, other tools. System performance tools like VMstat, IOStat, and Mon, etc. Should also know terminal multiplexes like Screen, Tmux. Team should know about the networking, security, and protocols like HTTP, HTTPS, SSL, TLS, SSH, FTP, SMTP, IMAPs, and all. Team should know what is and how to set up web server like Apache, Nginx, Tomcat, IS, and all. How to set up reverse proxy, load balancers, firewall, etc. are must. Infrastructure as a code in DevOps has been playing a vital role in doing faster and continuous deployment, and for this, team should develop skills in container-based deployment, tools like Docker, RKT, Alexis, and all. Configuration management and auto-deployment tools like Ansible, Shape, Puppet, Salt are must. Container orchestration tools like Kubernetes, Docker, Swarm, Mesos, Nomad, etc. has to be learned by the team. Infrastructure provisioning, Terraform, cloud formations are required. Nowadays, every application uses microservices. And for managing, microservices team should be having good understanding about service mesh architecture like ISTO, Envoy, Linkerd console, etc. Knowledge of any DevOps CI/CD orchestration tool is a must. So team should learn at least one CI/CD tool like Jenkins, TeamCity, Travis CI, Circle CI, etc. Now let's talk about continuous monitoring and operation, where we can learn to use infrastructure monitoring tools like Nagios, Zabbix, Centrion, Prometheus, and R. For application monitoring, teams should learn how to implement AppDynamics, New Relic, Jagger, Istana, Open Tracing in a project. For log management, we can use variety of tools like Elasticstack, Greylog, Splunk, Papertrail, and all. Cloud computing plays a vital role in DevOps roadmap nowadays. Teams should build knowledge base about managing applications on cloud like AWS, Google Cloud, Azure, Heroku, and all, and should also be familiar with cloud design patterns like availability, data management, design, and implementation, etc. Let me quickly add about continuous testing process, which is somehow not included in this diagram, but plays a vital role in DevOps automation process. Teams should be well versed with functional and non-functional test automation. For functional test automation, you can use Selenium, UFT, Silk Test, Auto IT, SOAP UI, and all. Non-functional testing such as performance, load, reliability, usability, you can use tools like JMeter, HP Load Runner, HP LM, and all. As you know, DevOps is a continual improvement process. Therefore, continuous learning is very much important throughout the DevOps journey. Let's now understand the successful DevOps implementation secrets. It is important that you need to start with small and step-by-step approach, since it's not recommended to change everything at once. It is important to get buy-in from all the individual stakeholders at your organization before you plan for implementation. Identify the right roles and responsibilities in the so-called DevOps team and make them accountable. Role could be like DevOps evangelist, automation architect, developer, tester, release engineer, and so on. Move security to the shift left to detect security threats at early stage and to get faster compliance feedback. Don't be afraid to fail. It is not likely that you are going to do everything right the first time you try. Things may go wrong, so learn from the experience, then adapt and change. Proactive monitoring and reporting to all the stakeholders will bring confidence and trust within team. That's all for now. Hope this helps you to plan, execute, and manage successful DevOps implementation at your organization. Please don't forget to like my video and subscribe my channel if you have not subscribed yet. And hit the bell icon to get latest update about my upcoming videos. Thank you so much for watching my videos. See you until next time. Welcome back to my YouTube channel. I hope you all are doing excellent. Today's video is all about the best open source tools for DevOps engineers. Whether you are a seasoned professional or just diving into the DevOps world, this is going to be interesting. So make sure to watch till the end. DevOps is a practice that bridges the gap between development and operations, fostering a culture of collaboration. It heavily relies on a variety of tools to streamline tasks, making the process more efficient and effective. In the DevOps environment, open source tools have carved a niche for themselves. They are known for their access and flexibility, making them indispensable in this fast paced domain. These tools support a wide range of tasks, including continuous integration, continuous delivery, and continuous monitoring. DevOps engineers leverage these open source tools for a multitude of tasks such as building, testing, deploying, and monitoring applications. This not only contributes to the evolution of modern software development and IT operations,
but also ensures effective application management. In the following sections, we will take a closer look at some of the best open source DevOps tools that are shaping the industry. We will start with continuous integration tools. And the first tool is Jenkins. Jenkins is a leading continuous integration tool providing developers with a versatile and extensible platform to automate various aspects of the software development lifecycle. Let's understand its key feature. Jenkins' robust plugin architecture is one of its standout features. It empowers users to tailor the CI/CD process to suit their specific project needs with a vast array of plugins available. Jenkins can seamlessly integrate with numerous tools and technologies and services, extending its functionality and flexibility. The ability to execute tasks in parallel is crucial for optimizing build times and enhancing overall efficiency in CI pipelines. Jenkins supports parallel execution, enabling developers to distribute tasks across multiple nodes or machines, thereby accelerating the build and test processes. Jenkins provides extensive integration with a diverse ecosystem of version control systems, build tools, testing frameworks, and deployment options. This versatility ensures compatibility with various development environments and enables teams to leverage their preferred tools seamlessly within the Jenkins pipeline. Jenkins support for distributed builds allows organizations to scale their CI infrastructure efficiently by distributing build tasks across multiple nodes or agents. Jenkins optimizes resources utilization and enhances throughput, enabling faster delivery of software. The vibrant and active Jenkins community support plays a pivotal role in driving innovation, fostering collaboration, and ensuring the platform's continuous improvement. With a wealth of user contributed plugins, documentations, and support forums, Jenkins remains a reliable choice for organizations seeking robust CI/CD solutions. In essence, Jenkins' combination of versatility, extensibility, and community makes it a preferred choice for organizations of all sizes looking to streamline their software development processes and adopt agile CI/CD practices. Travis CI is a widely used and well regarded continuous integration service that has been instrumental in automating testing and deployment for software development projects. Let's take a closer look at some of the key features and aspects. Travis CI supports parallel building, allowing multiple tasks or test suites to run concurrently. This can significantly reduce the overall build and test times, especially for projects with extensive test suites or complex build processes. The ability to customize environments is crucial for developers who work with diverse technology stacks. Travis CI allows users to define and configure their build environments according to project requirements. This flexibility ensures that projects using different programming languages, libraries, or dependencies can be seamlessly integrated into the CI CD pipeline. Travis CI is known for its broad support for multiple programming languages. This versatility is essential for projects that involve mix of languages or technologies. It allows developers to use Travis CI for a variety of projects, regardless of the programming languages being employed. Travis CI seamlessly integrates with GitHub, one of the most popular version control system. This integration is valuable as it automates the triggering of builds upon code changes in GitHub. This close integration with GitHub makes it convenient for developers already using GitHub as their version control system. The automated triggering of builds upon code changes ensures continuous testing throughout the development process. This is a fundamental principle of continuous integration where any changes to the code base are immediately validated through automated tests. Travis AI has cultivated an engaged and collaborative user community. This community serves as a valuable resource for developers, providing a platform for sharing insights, troubleshooting issues, and offering support. The collaborative environment contributes to the overall accessibility of Travis CI, making it user friendly for developers at all skills levels. Travis AI is praised for its intuitive and user-friendly interface. This ease of use is crucial for developers who wants to quickly set up and configure CI/CD pipelines without a steep learning curve. GitLab CI is a powerful tool integrated into GitLab that allows for automated testing, building, and deployment of applications. It uses a YAML file for configuration, enabling developers to create complex pipelines. With its robust features and flexibility, GitLab CI has become a popular choice for teams seeking efficient DevOps practices. These are the key features of GitLab CI. GitLab CI/CD provides seamless and integrated pipeline configuration within the same repository as the codebase. This simplifies the setup and maintenance of CI/CD workflows, ensuring a unified and efficient development process. Auto DevOps is a powerful feature that automates the entire CI/CD pipeline with minimal configuration. It automatically detects builds, tests, and deploys applications, reducing manual intervention and accelerating the delivery of software. GitLab CI/CD includes a built-in container registry, allowing developers to store and manage Dockers images directly within GitLab. This integrated registry streamlines the containerization process and enhances version control of container images. GitLab CI/CD enables the creation of dynamic environments for each branch and provides review apps, allowing developers to preview changes in a production like environment before merging. This fosters collaboration and ensures code quality and functionality. GitLab CI/CD utilizes a declarative YAML-based configuration, enabling developers to define pipelines and jobs as code. This approach promotes versioning, transparency, and collaboration, making it easier to manage and modify CI/CD configurations within the version control systems. GitLab Comprehensive and Integrated feature makes it a robust choice for team looking to implement end-to-end automation in their software development workflows. Next is version control tools. Git is really useful for DevOps because it helps keep track of changes in code efficiently. It lets developer work together easily, making sure the code stays reliable, versions are managed well, and teams can collaborate smoothly. Git is great at supporting teamwork by using strong ways to handle different parts of a project. Whether it is feature branches or Git flow, teams can work on different things at the same time, making collaboration smoother, reducing problems, and boosting overall productivity in DevOps. Another version control tool is Apache Subversion, also commonly known as SVN, is a kind of system that helps keep track of changes when people work on software together. It works from a central place, which is good for projects where you need strict control over who can do what. It is especially useful when dealing with lots of big files. SVN has been around for a long time and people like it because it is reliable and easy to use for keeping all the code changes organized. Next is configuration management tool. Ansible, a powerful open source automation tool, simplifies configuration management and orchestration of IT infrastructure. Known for its agentless architecture, Ansible allows seamless automation across a wide range of systems. Ansible excels in configuration management by enforcing consistency and automating repetitive tasks. Its declarative language ensures a desired state configuration, making it easy to manage and scale infrastructure, from provisioning servers to configuring network devices. Ansible streamlines various automation use cases. It integrates with cloud services, facilitating dynamic infrastructure management and supports continuous deployment pipelines in DevOps workflow. The vibrant Ansible community contributes to an extensive library of modules, enabling users to automate diverse tasks. These modules, coupled with Ansible's adaptability, empowers users to configure and manage systems efficiently. Chef, a popular configuration management tool, embraces infrastructure as code principles. Chef leverages the infrastructure as code approach, enabling users to codify infrastructure configurations. This ensures that infrastructure changes are version controlled, providing a clear and facilitating collaboration among development and operations teams. Chef organizes configuration tasks into cookbooks and recipes. Cookbooks contain the necessary configurations while recipes define the steps to achieve a particular configuration. This modular approach improves reusability and simplifies complex infrastructure management. Shape seamlessly integrates into DevOps workflows, supporting continuous integration and delivery. It's to automate configuration tasks combined with version controlled IAC contribute to faster and more reliable application development, a key aspect of modern DevOps practices. Next is containerization and orchestration tools. Docker is a pioneering containerization tool, is revolutionizing application deployment and scalability. Docker encapsulates applications and their dependencies in lightweight containers, ensuring consistency across diverse environments. Simplifying multi-container applications, Docker Compose orchestrates their configuration, linking, and execution, facilitating seamless deployment. Docker integrates seamlessly with continuous integration, continuous deployment, pipeline, ensuring efficient testing and delivery of applications. Leveraging Docker Hub, developers access a vast repository, fostering accelerating the. Another popular orchestration tool is Kubernetes. Kubernetes, an industry standard container orchestration tool, offers a robust framework for managing containerized applications. Kubernetes automates deployment, scaling, and management of containerized applications, providing fault tolerance and optimizing resource utilization. Rich features such as automatic load balancing, rolling updates, and self healing capabilities empower developers to build resilient, scalable applications. Kubernetes plays a pivotal role in DevOps, facilitating collaboration between development and operations teams, streamlining workflows and enhancing overall efficiency. A thriving open source community surrounds Kubernetes, contributing to its vibrant ecosystem. This community driven approach ensures continuous improvement and adaptation to evolving industry needs. Adaptation to evolving industry needs. Next comes monitoring and logging tools. Prometheus is one of the most famous in this category. Prometheus is an open source monitoring toolkit with a focus on metrics based monitoring. It employs a pull based model to collect metrics, features a powerful query language, and supports built in alerting. It seamlessly integrates with visualization tools like Grafana. Second most popular tool is ELK Stack. It is basically a combination of these three tools: Elasticsearch, Logstash, and Kibana. The ELK Stack is set of open source tools for log management and data visualization. Elasticsearch is distributed search and analytics engine. Logstash facilitates log processing, and Kibana provides a user-friendly interface for real-time analytics and visualization. Used extensively in DevOps, the ELK stack offers centralized log management with strong community support. For now, let's conclude this session. If you found this video helpful and enjoyable, don't forget to subscribe to my channel for more videos like this one and hit the notification bell so you never miss an update. Your support helps me create more valuable content for you. Thank you again and see you in the next video. Me create more valuable content for you. Thank you again and see you in the next video. Me create more valuable content for you. Thank you again and see you in the next video. create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create more valuable content for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again and see you in the next video. Create for you. Thank you again.